In virtually every Android app you use today, there's some type of data being sent or received via a web service. Whether you're checking your bank balance or clicking like on a photo, behind the scenes, data is being transmitted. In parts 1 through 3 of this essential training series, we introduce the fundamentals of Android development. In part 4, we'll focus on how you can use data to make your applications more useful and engaging. We'll cover how to use Android resources to store your app's data locally. You'll learn how to use modern libraries such as Moshi and Retrofit to download and present remote data to users. And finally, you'll discover how to use the RecyclerView component to present dynamic data inside of your application. I'm Annyce Davis, and I've worked in the software industry with top companies for over a decade. I hope you're ready to join me in part 4 of my LinkedIn Learning course, all about the essentials of Android development. This course is designed for software developers who are learning to build Android mobile applications. You should be familiar with Android fundamentals like activities, theming, and view components. Additionally, modern Android applications are written using the Kotlin programming language. Having a working knowledge of Kotlin is essential. To get the most from this course, I would highly recommend you enhance your Android knowledge by taking the following courses: Android Development Essential Training Parts 1 through 3, Android Studio Essential Training to get the most from the IDE that we'll be using to develop our apps, and finally, Kotlin Essential Training, so you can have a strong grasp of the Kotlin programming language. The exercise files for this course are stored on GitHub. There are branches for both the start and end states of each video where we work on code. You can view a list of all of the branches here in GitHub from the branch drop-down menu. For example, if you wanted to find the start state for video 0302, add a RecyclerView to a fragment, then you would change to the 0302B branch, and the ending state would be in the 0302E branch. There are multiple ways to work with this project in Android Studio. One simple way is to copy the URL from the code button. So we'll copy this, and then we'll move over to the Android Studio welcome screen to check it out. We're here on the welcome screen in Android Studio. I'm going to click on the Get from VCS button. Make sure I've selected Get from the version control options, and then I'll paste in this URL. Next, I'm going to click the Clone button. You may receive a few dialogues asking if you want to add the files to Git. Just ignore those. But chances are, by the time you download the files, there will be updates to Android Studio and the associated plugins. If you receive a dialog asking you to upgrade your dependencies, please do so. Then wait for the project to sync. It typically takes longer when the project loads for the first time. Once it's complete, however, you're ready to work with this version of the code. By default, we're running the code from the main branch. As I mentioned earlier, I've created branches for each video in the course where we modify code. If you'd like to follow along, you want to use the branches pop-up menu in the lower right corner to change to your desired branch. As an example, I'm going to click on the branch pop-up menu, and then I have a list of branches. Let's check out the code for the start of the 0302 video. I'm going to click on where it says Show 36 More, and then I'll scroll down to 0302B. And then I'll select Checkout. Once this is checked out, we can rebuild our project to ensure that we're working with the code from this newly selected branch. Once that's complete, then we're ready to work with this version. If you run into trouble checking out the different branches or using Git in general, I recommend searching the library for the Git Essential Training videos. One of the most common types of data that you'll need to support in your Android app is JSON. JSON is a lightweight data format. It's easy for humans to read and write, as well as for machines to parse and generate. This is the JSON data we'll be working with. It contains product information for various bottles of olive oils. In Kotlin, you can represent the contents of JSON with data classes. To get started with creating our data class, I'm going to first create a new package named Data. I'll come over to our primary package, right-click, and I'll go to New, Package, Data. Then, inside of this package, I'm going to create a new Kotlin class called product. Once again, I'll right-click, go to New, Kotlin class or file. I'm going to choose class, and the name will be product. In order to prepare our class, I'm going to grab the contents of one of the JSON objects from our file to use as a reference. So I'll come back to our JSON file, and I'll just highlight the first object, copy that, and then I'm going to paste it at the top of our product class. Great, we'll be deleting that soon. We're going to start by adding the data keyword here in front of the class keyword on line number 11. This is what allows the compiler to generate a few helpful functions for us, like toString, copy, and getters and setters. Next, we'll remove the braces, as they're not needed when you're only using the data class to declare properties. And in its place, we'll put a pair of parentheses. We can use this as our class declaration as well as our primary constructor. Now let's get to creating our properties. We want to create a property for each element in our JSON object. Now when it comes to creating the properties, we can either declare them as vals or vars. If the property can change, use a var. If it can't, use a val. In our case, we're not going to change any of the properties, so we'll use all vals. Let's get started. Our first property is name. We'll declare it with a val, and we can see that it is of type string. That's it. Let's go to the next one. Image file. Once again, it's of type string, and since we've decided it's not going to change, we're going to use a val. Pretty straightforward. And we'll do the same thing for the description. Next, we see a different type for size. This is going to be an integer. So we'll copy the size keyword, and we'll declare it as an int. And then finally, since the price has a decimal value, we'll declare it as a double. We'll copy that, val, price, and we'll declare it as a double. And that's it. We've created a data class named product that mimics the structure of our JSON object. Let's go ahead and delete this JSON sample. Now our class is ready to go. To try it out, we're going to go over to the shop fragment and create an instance of the product data class. So we'll move over to shop fragment, and inside of the onViewCreated function, let's create an instance of our product class. And we can do that right underneath here where we've declared the view model on line number 31. We'll start by defining a new variable, product. It's going to be of type product. And then we can fill in all of the properties that we just created. But first, let's import our newly created class. And inside of product, let's set the properties. First, there was name. And we'll set this equal to item. And this data is just for us to test it out. The image file, let's call that one image_file. Description, we'll say this is my description. Then we have the size, and we'll set that equal to 200. And then finally, our last property was price. And let's set that equal to $12.35. Okay, we fully defined our product object. Now let's print out this product to our logcat. To do that, we'll come underneath where we've defined the product. In here on line number 40, let's start typing log.i. And then we're going to go ahead and import this. And we can do that using our intention action, Alt Enter, and then we'll provide the tag. So we can find it easier later. Let's type 2_trees_oil to use as our log tag. And then we're going to print out the statement, my product. And we'll use the $sign in order to take advantage of the product variable. That's it. Let's go ahead and run our application. Since we've made these changes on our shop fragment, we need to go over to our emulator and navigate there first. We'll go over to the emulator, then we'll click on shop, And now we can go back and check out Logcat. When we open up our Logcat, we see a lot of things printed out, but let's trim it down to our log tag, 2trees_oil. And there we have it, our sentence, my product, and then the two-string representation of our product data class. As you've seen so far, Kotlin data classes are simple to create and use. They offer pre-built functionality that makes it easier to work with data in your Android applications. One way to package data with your app is to store it in resources. As I mentioned previously, JSON is the most common format used these days, but you can store other types like XML or CSV. Our app already has a JSON file, oliveoilsdata.json. It's stored in a resource directory named raw. This is where you want to place any resource files that you want to keep in their raw or original format. To load our JSON data into memory, we'll use a function available on the resources class. But before we get to that, we'll create a new class to serve as an abstraction layer between the resources call and our view model. To do that, we're going to use our data package. Then we'll right-click and go to New, Kotlin File or Class. Here we're going to select Class, and this is going to be named Product Repository. Our Product Repository class is going to contain one function for now, get text from resource. To add that, we'll put a little bit of empty space and we'll create our new function. And as I mentioned, this is get text from resource. And it's going to take in two parameters. First, a context object, which we'll name context. And this is going to be from the Android content package. Next, it'll take in an integer named resource ID. And we'll use this to represent the raw resource file. And finally, it will return a string, which is our JSON data. We'll start the function body by typing a return statement, and then we'll make a call to context.resources.openRawResource. This is what's going to allow us to get access to our raw JSON file. It accepts a value, ID, in the form of an integer, which is where we're going to pass in our resource ID. Next, we're going to make a call to the buffered reader. This allows us to handle the file reading more efficiently. And then finally, we'll make a call to the use function. This Kotlin function allows you to take action on a resource like reading from a file, but then it closes the resource correctly after the operation is complete. So it saves us from having to write a bunch of boilerplate code ourselves. And inside of the use block, we're going to make a call to it.readText. And that's it. Everything we need in order to read our raw JSON file from the Android resources system. With this file completed, let's move over to the shared view model class to use our product repository and its function. Let me go ahead and close down the project pane so we have a little bit more space. The first thing we want to do is create an instance of our product repository. And we can do that here on line number 12. We'll create a variable, product repository, and then we'll go ahead and create a new instance. Great. Next, we're going to create an initialization block so that we can call our getTextFromResources method whenever the view model is first created. And we'll do that right underneath this as well here on line number 15. We'll use init, and inside we'll make a call to the product repository.getTextFromResource. Now remember, this function takes in a context as well as a resource ID. But where are we going to get a context from? In order to provide this, we'll have to make a slight modification to our shared view model. Instead of having it extend view model directly, we're going to change this to the Android view model class. And let's go ahead and delete that portion. What's special about the Android view model class is that it takes in the application, so you can safely get access to a context object whenever you need one. We'll update the definition of the shared view model to take in an app, and then we'll pass that to the Android view model's constructor. and all of those errors disappeared. Next, we'll come back to line number 18 so we can finish up calling our function. We'll pass in the app as an application extends context, and then we'll enter the raw resource ID, which is r.raw.oliveoilsdata. Remember, we don't use the file extension when we're working with Android resources. Now that we have our call in place, let's set this equal to a variable that we can print out to logcat. For now, we'll call it data. Then we'll add our log statement. We'll use our familiar tag, 2treesoil, and we'll pass in the data. That's it. Let's run the app and check out the logs. Great, the launch succeeded. Let's move over to our emulator. When we come here, we see our same 2trees olive oil application. We're on home, we have tours, and the shop. Let's go ahead and make sure it printed out our statement from our shared view model. Moving back to Android Studio and opening up logcat, if we scroll up a little bit, we see our entire JSON printed out. And this came directly from the shared view model. Perfect. Now you've learned one way that you can read files from resources. We've learned that we can store files in our application as a raw resource. This allows us to reference those files the same way we do many other Android resources, with the use of the R class. You can also store files as assets. Assets have the same performance as raw resources, yet you access them by their full name and as a string value. Assets are often used when the file name of your resource needs to be arbitrary, or you want to store the data in subdirectories. Let's create an asset for our JSON data file. We'll create a new folder by right-clicking on the app folder. We'll go over to New, down to where it says Folder, and then we'll choose Assets Folder. We'll accept the defaults and click on Finish. Notice how this has created a new folder named Assets inside of our application. Next, we'll copy our JSON file from the raw folder. So we'll right-click, we'll go to Copy, and then choose Copy. And then we'll paste it inside of Assets. We'll stick with the defaults and click on OK. And now we have our JSON file available as an asset. In order to read from our asset file, we'll add a new function inside of the product repository class. Let's close down this pane and go to the product repository. Our new function is going to be very similar to the existing one, getTextFromResource. So we'll copy it as a template, and then we'll paste it down below. Let's make a few changes. First, we'll name this one getTextFromAsset. And then, instead of taking in a resource ID, we're going to take in a string, which we'll name FileName. And as I mentioned, this will be of type string. Next, let's delete what we see here on line number 14 all the way up until resources. Instead, we're going to make a call to the assets function. This gives us access to the asset manager, which is how we can open files. Next, we'll choose the open method, and then we'll pass in our file name parameter. Everything else is the same. To use this new function, we'll move back over to our shared view model class. Here, on line number 19, we're currently making a call to the getTextFromResource function. Instead, we're going to make a call to the getTextFromAsset function. Let's delete everything up to the word from, and we'll pop in asset. Just like the previous function, we rely on a context, which we can get from our application class. And for the file name, we're going to pass in the following string: olive_oils_data.json. Remember, for assets, you have to put the full file name, including the extension. That's it. Let's run our app and check out the logs. If we move over to our emulator, we see that our project does indeed load up and we can access the various screens. Going back to logcat, notice how we get exactly what we were expecting. The entire JSON output but this time it came from the asset file. Depending on the needs of your application, you now have two ways of packaging files in your app, using resources or assets. Choose wisely. When you're working with JSON data in your application, you initially load it into memory as a string. However, once you need to use that data throughout the rest of your app, you'll need to convert the string to an actual data object. The process of converting a JSON string into a data object is known as deserialization. Its inverse, serialization, is how you would convert a data object into its JSON representation as a string. There are several popular libraries for doing so in the Android community: JSON, Moshi, and Jackson. They each have their various strengths and weaknesses. In this course, we'll use Moshi, as the library size is small and it has great support for Kotlin classes. Let's move over to Android Studio to add Moshi to our project. To get started, we'll add in the Moshi Kotlin dependency. I'll do that here on line number 48. I'll start by typing implementation, and then I'll include the dependency. It's from com.squareup.moshi, and it's Moshi Kotlin. As of this recording, the version is 1.11. I'll go ahead and sync the project to download the new dependency. Next, we'll move over to the product repository class. Remember, this is where we had our functionality for loading our JSON file into memory, so this makes the most sense in order to deserialize it as well. To get started, we're going to create a new function, and I'll do that right here starting on line number 19. This function will be named getProducts. It's going to accept the exact same parameters as the getTextFromAsset function, the context and the file name. So I'll copy those parameters and I'll paste them inside of the getProducts function. However, as the difference, we're going to return a list of product objects. Next, we'll start by creating an instance of the Moshi class. We'll create a new variable named Moshi, and we're going to set that equal to Moshi.builder. And we'll use an intention action in order to bring in that import. Next, we'll add in a type adapter factory in order to support Kotlin JSON. We'll click Add, and we'll type in Kotlin JSON adapter factory. Once again, let's use an intention action to bring in that import. And finally, we'll make a call to build. This gives us everything we need for our instance of Moshi. The next variable we'll create is a parameterized type. We'll name this one val_list_type. And we'll use the types function from Moshi called new parameterized type. This particular type will assist Moshi in understanding how it should parse our JSON array of products. Inside of the new parameterized type function, we're going to pass in two values. First, the list, and then our product. And once again, let's use an intention action to bring in the import. We're almost there. We'll have to create an adapter that we'll use to do the actual deserialization of our JSON. Moshi uses the concept of adapters to control how the data in your JSON is converted to and from. Underneath where we've declared the list type, we'll also create our adapter. This adapter is going to be of type JSON adapter, and it will return our list of products. Once again, an intention action to bring in that import. And we'll set this equal to Moshi.adapter. And we'll make sure we pass in our list type as one of the values to this particular function so that Moshi can properly parse our JSON for us. And now the very last step. We're going to return the results of calling adapter.fromJSON and then we're going to pass in a JSON string. Remember, we can grab this string from our getTextFromAsset function. This function accepts the context as well as the file name. Notice how we're receiving an error from this particular line, and when we highlight over it, we get a message that we required a non-nullable list of products, but the Moshi from JSON function could potentially return a nullable list of products. In order to address that, we'll simply add a question mark to the end of this function in order to show that it can receive a nullable list of products. And that's it. Let's switch over to our shared view model class for the very last step. Here, inside of our initialization block, we originally made a call to the getTextFromAsset function, and then we printed out the string that we received back. Instead, we're now going to make a call to our getProducts function. Remember, it takes in the same exact parameters. We now have a list of products. What we want to do is print out the name of each product one at a time. So we'll come here to line number 19. We'll get access to our data object, which contains our list of products. We'll use the question mark since we know that it could potentially be nullable. And then we'll make a call to the forEach function. Inside of the forEach function, we're going to use our log statement. And instead of simply printing out data, we're going to print out the string, product, colon, then we'll use the $, and we'll print out the name of the product. That's it. Let's go ahead and run the app. Let's go ahead and open up the logcat. Notice that we have a separate log statement for each of the JSON items that were converted to our product data objects. By means of Moshi's adapters, you've been able to properly deserialize JSON. Great work! We're currently able to process a JSON file using Moshi, the result of which provides us with a list of our product data class objects. This works because the name of each field in the JSON file matches exactly with the property names of our data class. For name, we have name. For image file, we have image file, and so forth. Let's see what would happen if that weren't the case. We're going to switch over to our JSON file, and we'll rename the name element to product name. To do this, I'm going to select name, go up to Edit, Find, and then Replace. Instead of name, we're going to use product name and then replace all. We can close this down and you'll see that each of the name elements has been replaced with product name. Let's run our app and inspect the logs. Now that the launch has succeeded, we'll go down to logcat and notice that we have a lot of errors. Primarily, if you notice here, Moshi is letting us know that there's a JSON data exception because the name property is missing. So instead of getting back a list of the names like we did previously, we get back this exception. And that is the default behavior when Moshi is unable to map the values from your data class to what's provided in the JSON. Since you won't always be able to control this, Moshi ships with an annotation that allows you to handle this scenario. If we go back to our product class, we'll close down logcat, move over to product. We're going to add an annotation to the name property here on line number 12. That starts with @JSON. This is available from Moshi, so we'll use an intention action to bring in that import. Next, we'll have to supply the name property, and we're going to set that equal to product name, as product name is the value that's provided in our JSON file. That's all we need to do. Let's run the app again and confirm that we're now getting back the correct data. Okay, our build has succeeded. We're going to open up logcat. Let's clean up our filters so that we're looking for info, as well as our correct application. And indeed, we see all of the product names available. By means of the JSON annotation, you can now name your Kotlin data classes whatever makes sense for you, regardless of what's specified in the raw JSON file. You'll find this comes in handy as you work with various types of APIs. Hey folks, it's time for a challenge. We're going to put your JSON parsing skills to the test. Here's what you'll be implementing. It's a simple stock ticker. There are a few main elements: buttons to choose the stock symbol, a text view which displays the selected symbol, and another text view which displays the stock information, such as the open and close price, along with the change. Let me show you a few examples. I'll click on the first symbol, and then below, the two text views are populated. And then I'll click on the next one, and the information is updated, and so forth. Let's move over to Android Studio to take a look at what you'll need to implement. First, I've created a skeleton application for you in the exercise files. Make sure you start there. Let's walk through the application. You'll be working with the JSON data stored in the raw resources folder, stockdata.json. Each JSON object contains several fields, like the firm ID, the open and high price, as well as the low, close, and change. There are exactly 3 different records inside of this JSON file. This data is read and parsed in the stock repository class. So let's move there next. When the class is first created, it loads the JSON into memory and uses Moshi to parse the data and store it inside of a list of stock objects. We can find that function in the Get Stocks here on line number 28. This should be familiar to you, as we did the same thing previously with our olive oil JSON data. The one thing that is new is our function which starts here on line number 37, Get Stock Data for Firm. This provides the caller with the ability to choose which stock record they're interested in by sending in the firm ID. We use this function inside of our main view model. So let's move over to there next. This class should look extremely familiar. We declare our LiveData objects so that our fragment can observe the changes, and then we expose a function, getStockData, here on line number 17. This takes in a firm ID and passes it to our repository class. If we receive back a stock object, then we update our LiveData instance. Hopefully you're nodding your head as we've done this many times before. Next, in the stocks fragment class, we're going to get started with the onCreateView function here on line number 19. Beginning on line number 26, we set up our observer to listen for any changes to the stock info. Then, on lines 30 through 40, we have a series of on-click listeners that are already wired up to the buttons that we saw on our stock ticker screen. For button number 1, we make a call to the view model's getStockData function, and we pass in a firm ID of 1. And we do something similar for button 2 and button 3. We then have one final function here in this class on line 45, update stock info. This is where you'll need to make a change. I've implemented the first half of the function for you. It gets the firm ID of the provided stock, and by means of a when statement, it updates the label with the name of the firm. The next step is to display the open, close, and change information from the stock. To do that, you'll have to add the needed fields to the stock class, and this is the second and final change that you'll have to make. Let's move over to the stock class. As you can see here, the stock class constructor is empty. You'll need to add the missing properties that will ensure Moshi can properly parse the JSON. If you get stuck, refer back to previous videos where I walk through how to map JSON and class fields. Additionally, make sure you watch the solution video where you'll see how I tackled this challenge. See you soon! Welcome back. Let's jump into my solution to the Show Me the Data challenge. For this challenge, I wanted you to update a skeleton application to process a bare-bones stock ticker. The app does the following. It has several buttons to choose the stock symbol, a text view which displays the label of the symbol, and another text view which displays the open, close, and change information. Whenever you click on a button, the stock information updates below. Let's move over to Android Studio to check out the changes. We'll start with the stock class. Although the JSON data had several fields, we only needed 4: the firm ID, the open, the close, and the change numbers. For the firm ID field, I had to add the use of the @JSON annotation. This is because the code assumed that the property for the firm ID was in camel case, whereas the JSON data provided the value in snake case. Remember, by means of the @JSON annotation, you can name your properties what you like, regardless of what's in the raw JSON data. Next, I called my new properties in the stocks fragment class. That's here, starting on line number 52. The stock info string expected 3 input values: the open, close, and change information for a given stock. And that was it. That was the final change that was needed to complete this challenge. Want to take it up a notch? You can add more sample data to the JSON file and perhaps show multiple records in a text view. Or you could calculate the average stock data for a given firm or something else entirely. You're developing more and more skills as you move through the course. The best way to make the knowledge your own is to practice and have fun while doing it. I hope you enjoyed this challenge, and I'll see you soon. So far in our sample application, we're able to read JSON data stored in a local resource file, load it into memory, and then parse it using Moshi. Inside of our shared view model class, we simply print out the list of products one by one. To take this to the next level, we want to share the data with the shop fragment class so that users will know what products we have available for purchase. To do that, we'll make use of LiveData. We've used the LiveData instance to increment and decrement the product count. Now, we're going to create a new mutable LiveData instance to store the list of available products that we received from our repository class. We'll do that starting right here on line number 15. We'll create a new variable, file products, and this is going to be of type mutable LiveData. It will contain a list of our product objects. And we'll set that equal to a new mutable LiveData instance. Then, in our initialization block, instead of printing out the list of products, we'll set the value of our mutable LiveData instance. We'll come here, we'll delete lines 22 through 24. We'll use the list of products received from the data repository, and then we'll do $.let. We're taking this safeguard as it's possible that we don't receive back a list of products and the data variable is null. Next, we'll update our mutable LiveData instance, products.value, and we'll set that equal to IT, which represents the list of products. Now that we have our mutable LiveData connected, we want to set up the shop fragment to observe the changes. Let's move over to the shop fragment, and inside of our onViewCreated function, we're going to get a reference to the view model, then the products, and then we'll call the observe function. This function takes in 2 parameters, the lifecycle owner, as well as a lambda, which denotes what we want to be executed when a change is observed. Let's hit enter, and for our lifecycle owner, we're going to provide the view lifecycle owner. And then for our lambda, we want to display the list of available products to the user. If we take a look at the fragment shop.xml layout file, notice that it contains a text view, cart content text. This property is available underneath the Our Products heading. We'll use this text view to display the list of products. Moving back to the shop fragment, we'll start by creating a list of the various product names. We'll do that by creating a string builder, which we'll name product names. Then we'll loop over each product that we receive. And for this to work, we need to define our variable from the Lambda. So instead of using the default IT, we'll replace it with products. Great. Next, we'll add a new line for each of the products. We'll do product names.append line. And for the value, we're going to pass in the it.name or the specific name of the product. And then finally, we're going to display this inside of the text view. We'll do that by making a call to the binding.cartContentText and then setting its text value equal to our product name string. Now notice we have an error here on line number 31. That's because it's possible that the view model is nullable. So we'll use some question marks in order to properly reference this. And that's it. Let's go ahead and run the app and check out our changes. We'll move over to the emulator, and when we click on the Shop tab, we have our list of products displayed properly inside of the text view. By means of LiveData, we're able to seamlessly retrieve and share information with our user interface. The majority of the apps we use on a daily basis are powered by web services. The data that we see is retrieved from the cloud and then parsed behind the scenes on our device. On Android, this data retrieval and parsing is often handled by HTTP clients. These clients allow you to communicate with a server over the HTTP protocol. Think get, post, patch, and delete. In addition, they provide the ability to request typed response objects, offer streamlined error handling, straightforward testability features, as well as request and response interception. Some of the most popular libraries at the time of this recording are Ktor, OKHTTP, and Retrofit. They each have various strengths and weaknesses. But for the most common case, that of downloading some JSON data from a remote URL, they're pretty much the same. In this course, we'll be using Retrofit. It's by far the most popular, and if you ever run into any issues, you can find tons of resources online. Retrofit was designed by the team at Square. It has branded itself as a type-safe HTTP client for Android and Java. However, it works smoothly with Kotlin as well. You'll see this shortly. By means of interfaces and annotations, Retrofit makes working with your API a breeze. In order to set up our app for loading data from a remote web service, I've uploaded our JSON to a folder on the youcanlearnit.net domain. We'll use this URL to interact with Retrofit to download the JSON. But let's move over to Android Studio. To get started, we'll need to add a few dependencies to our application's build.gradle file. The first dependency is going to be for Retrofit itself, and then the second one is going to be for the converter. I'll paste those here starting on line number 51. As I've mentioned previously, Retrofit supports various serialization libraries like JSON, Jackson, and Moshi. Depending on the library that you choose, you'll also need to pull in its corresponding Retrofit converter. With that done, we can now sync our project. We now have the classes available to us to create an instance of Retrofit. We'll do this in our product repository class. Currently, we're still loading the JSON from raw resources. We'll leave that as is for now, but we will be removing it shortly. The first thing we're going to do is create a constant that points to the URL which contains our JSON. Let's do that right above where we've defined the class. Here on line number 10, we're going to create a const file. We'll name this base endpoint URL. And then we're going to set it equal to the string https:// and then our domain. We're not including the entire URL, only the domain. That's because we're going to use the path later on. Next, we'll create a private variable to store our Retrofit instance. We'll do that inside of the class definition, starting here on line number 14. This is going to be a private val, and we're going to name it Retrofit. It's going to be of type retrofit, and we'll take advantage of Kotlin's lazy property in order to create it. By using lazy, this allows us to create the retrofit instance the first time it's needed, and then return the same instance each subsequent time it's requested. Retrofit uses a builder pattern to create an instance. So first we'll need to create a new retrofit builder and set up a few properties. We'll do that by typing retrofit.builder. We need a new instance of the builder class, and then we're going to first set the base URL. We'll use the constant that we created up above, base endpoint URL. Next, we need to supply a converter factory. This is how Retrofit knows that we want to use Moshi for our parsing. So we'll choose the function addConverterFactory, and then we'll provide a Moshi converter factory. Similar to Retrofit, this also uses a builder pattern. And then the final thing we need to do is add the build call. And this will create our instance of Retrofit. One thing that's special about our case is we've already created a Moshi class. Let's grab that from below. File Moshi. This entire line, line number 30. This is our previous instance of Moshi that we created. And we want to provide that to our converter factory. So we'll come up here on line number 17. We'll paste this instance of Moshi, and then we'll add it as an argument to our create method. That's it. We've now got Retrofit set up. The next step is to create an interface that we can use for executing our requests. To use Retrofit for your API requests, you'll need to define an interface. The interface contains various functions that map to your desired API routes or requests. When working with Kotlin, the format of your functions will be similar to what you see here. First, we have an annotation declared, which represents the HTTP method you want to be performed. This could be get, put, post, etc. And then for the value of the annotation, we provide a string that represents the path to the resource. Next, notice that the function is declared with the keyword suspend. Suspend functions are a core element of coroutines. Coroutines are one way of handling asynchronous work in Kotlin. If you recall, when working with Android, you never want to block the main thread. It's used to process join events, among other things. If you block the main thread, then users will think that your app is just hanging. And this is where coroutines come to the rescue. When a request for a long-running process is initiated inside of a coroutine, the coroutine can pause or suspend work on the current thread. Then it will perform the required job on a network thread. Once it gets a response, it resumes from where it left off. This is just what we want to ensure that we never block the main thread for our users. Now let's go back to our Retrofit interface. Next up is the method name. This is typically something relevant to the call that you're trying to perform, like get books or delete user. And finally, we have the return type of our function. It's a retrofit parameterized response object. It takes in the type, which corresponds to a class in your application that matches with the API response. Now that you understand the fundamentals of coroutines and Retrofit, let's go ahead and create our interface. As a reminder, this is the remote URL that we'll be using to download data with Retrofit. We've already created a constant that contains the domain. Now we'll just grab the path, oliveoilsdata.json. We'll use this as the value we provide to our get annotation. Back here in Android Studio, we'll create a new interface in our data package. So we'll come to Data, right-click, go to New, Kotlin class or file, and we're going to choose Interface this time. And we'll name this Product API, and then hit Enter. Inside of our interface, we're going to need a function. We'll call this function getProducts. Let's go ahead and close it down this pop-up. We'll come inside of our interface, and we'll add our function, suspend, fun, getProducts, and it's going to return a response from Retrofit, which will be our list of products. Remember, we're using a suspend function because we don't want to block the main thread when our function gets called. Now, our final step is to define the annotation. This corresponds to the HTTP method that we want to be executed. For us, we're going to be making a GET request, so we'll use the @GET annotation. And for its value, we'll provide a string that contains the path to our JSON file, which was that oliveoilsdata.json that we copied previously. So I'll paste that here. With that complete, we can move over to the product repository class and create an instance of our new product API class. To do that, we'll close down this panel and we'll go over to the product repository class. And just like we did before, we're going to make a private variable of type product API. Let's do that right underneath where we've defined the retrofit variable. So I'll type private val. This is going to be our product API. And we'll select it. And we'll also create it lazily by using the byLazy lambda. Once again, we're doing this so that we only have one instance of the product API class available. And to create it, we'll use our retrofit instance, and we'll use its create method. This takes in the class, which is our product API class.java. And that's it. You've now learned how Kotlin coroutines allow us to avoid blocking the main thread. Retrofit by means of annotations and the suspend keyword enable us to configure our application to perform network requests on a background thread. Next up, we'll actually make the API request. So far, we've learned that coroutines allow us to perform asynchronous tasks without blocking the main thread. This is perfect for Android development, as we want to ensure that the main thread is responsive to user actions and drawing commands. In Kotlin, all coroutines run inside a coroutine scope. The scope controls the lifetime of its coroutines. When you cancel a scope, it cancels all of its child coroutines. On Android, when a user navigates away from an activity or a fragment, it makes sense to cancel any started coroutines because they're no longer interested in that work. This is where scopes come into play. They automatically cancel that work without you having to do anything. Coroutine scopes exist for the majority of the Jetpack components, such as Lifecycle, ViewModel, and LiveData. These scopes allow you to start coroutines that are associated with the lifetime of the components. This is great because when the lifecycle is stopped or the ViewModel is cleared, the coroutines are automatically canceled. This ensures that users have the best experience when using your app. Let's move over to Android Studio, where we'll use the LiveData coroutine scope to read our remote data with Retrofit. The Android X Lifecycle LiveData KTX library adds a coroutine scope to LiveData. This allows us to build the LiveData value from code that can be suspended. To use this library, however, we need to add it to our apps build.gradle file. We can do that here. We'll come to line number 44, hit enter, and we'll add a new value for implementation. And this one's going to be Android X .lifecycle lifecycle live data. And let's not forget the KTX. And that's it. Let's go ahead and sync the project. Okay, with that done, we can now move over to the product repository class to make use of our Retrofit API. We'll come over to product repository, and down at the bottom in our get products function here on line number 35, we'll update this to use Retrofit. So let's go ahead and delete everything we have inside, and we'll start by making a call to the product API .get products function. Now this is going to return back a response. Let's capture that response inside of a variable, and we'll simply name it response. Whenever we get an API response, it can either be successful or it can fail. So we want to be able to capture that information. To do so, we'll start with our return statement, And then we'll add an if check. If the response is successful, then we can use the response body in order to get the information, namely our list of products. So we'll use response.body. Now our body's response could be null, so we want to add a check for that. And in that case, we'll just return an empty list. And we'll do the same thing if the response was not successful. So we'll add our else statement, and we'll also return an empty list. Now that's everything that we need in order to run our request. And let's just update the return statement from being nullable to non-nullable. Now currently we see an error happening here on line number 36. And if we hover over that, we see that the suspend function getProducts can only be called from a coroutines or another suspend function. So to fix this issue, we want to make sure our getProducts function is also a suspend function. And that's it. We've now updated this function. Notice, however, that we no longer rely on a context, so we can simply remove it. We can now remove this code we no longer need, namely this function getTextFromResource. And if we scroll up to the top a little bit, we should be good to go. With that done, we can update the shared view model class. Moving over to there, we no longer need this initialization block. So let's delete it. And instead, we're going to use a LiveData function. Right underneath where we've declared our product repository, let's create a new variable, val products. This is going to be of type LiveData, and it's going to contain our list of products. And we're going to set this equal to our new function, LiveData. This is the result of adding the LiveData KTX library to our project. This function is going to take in a lambda that contains our suspend function. That function that we're going to call is from the product repository class. And we'll set this equal to a variable that we name data. So we'll call product repository dot get products. And then finally, once we get the data back, we'll call the emit function and we'll pass in the data. And now let's go ahead and delete line number 17 because we no longer need this reference to the products. Now, one thing I want to point out about our new call is the fact that in the gutters, you see these cool little icons. That's what helps us to see that these are suspend functions. So that's always useful when you're working with coroutines inside of Android Studio. The last thing we want to do is to ensure that we have the internet permission defined in our Android manifest file. This is required in order to make any network requests. So we'll go over to the Android manifest. Right above where we've defined our application, we'll add uses permission, and the name is going to be internet. That's it. Let's go ahead and run the app. We can move over to our emulator. Our application is loaded, and then we're going to click on the shop icon. And notice that slight delay, and then we got our list of products. Just like before, we did get a list of products. However, this time, we've loaded the data from our remote URL without blocking the main thread. We've only used the very basics of what Retrofit has to offer. To learn more, I encourage you to take this course all about using Retrofit for Android development. A RecyclerView is a UI widget that makes it easy to display a dynamic list of items. You supply the data and define how each item looks. Then the RecyclerView dynamically creates the items when they're needed. It even reuses or recycles views whenever it makes sense. This is where it gets its name from. Several different classes work together to build your dynamic list of items. First up is the RecyclerView. It's the view group that contains the views corresponding to your data. Since it's a view itself, you add RecyclerView into your layout the same way you would any other UI element. Here's an example of defining a RecyclerView with XML. Next up is the view holder. Each item in your list is defined by a view holder object. The RecyclerView is responsible for binding the view holder with its data. You define the view holder by extending the RecyclerView.viewHolder class. Moving on to the adapter. The adapter is responsible for supplying the data and view holders to the RecyclerView. To work with the adapter, you'll need to extend the RecyclerView.adapter class. You'll also have to implement the following methods: onCreateViewHolder, getItemCount, and onBindViewHolder. The final piece of the puzzle is the Layout Manager. A Layout Manager is responsible for measuring and positioning the items within a RecyclerView. There are several different types of layout managers. A linear one for displaying items in a vertical or horizontal scrolling list, a grid layout manager for putting items in a grid formation, and more. You can even create your own custom layout managers. And that's it. You now know how each of these components works together to deliver an efficient experience for your dynamic lists with RecyclerView. Previously, we simply displayed our list of products inside of a text view. Now that you're familiar with the capabilities of RecyclerViews, we'll switch to using it instead. To get started, we'll clean up our shop fragment layout file. Let's remove the views that we no longer need, such as the quantity buttons, as well as the cart content text, and we can simply delete those. Then, we'll pick the RecyclerView from the palette and drag it into our layout file. With that in place, we can set up a few attributes so that we can take advantage of the RecyclerView later. The first thing I want to do is set an ID, and we'll do that here in the Attributes pane. And we're going to name this Product List. Okay. Then, instead of having this hard-coded layout width and height, we're going to pick Match Constraints from the dropdown. Cool. The next thing we want to do is properly constrain our RecyclerView inside of our constraint layout. So we'll come down to the Constraint widget, and we'll pick the right, the left, as well as the bottom of the parent. But instead of these large numbers, we're simply going to choose 8 dp for the left, the bottom, as well as the right. And now the final constraint that we want to set is the top of the RecyclerView. And we want to constrain that to the bottom of the Our Products text view. So we'll click this little circle and we'll drag it up to the very bottom. Perfect. And now let's go ahead and set an 8 dp margin there as well. Great. Now we have our RecyclerView just the way we want it. With that done, we can move over to the Shop Fragment class to do a little bit of cleanup. We'll come to the Shop Fragment, and here inside of the onViewCreated function, you see that we have an error because we deleted this text view. Let's go ahead and remove all of this previous code that we had, which displayed the product names inside of the text view. And that's everything here from lines 32 to 37. We'll simply delete it. And that's it. We've got our RecyclerView in place, and now we'll move on to creating the other components that work together to display our dynamic list. Each item that we display inside of a RecyclerView needs to have an associated layout. Let's create a new layout file that we can use for displaying the individual products in our list. I'll start by coming to the Layout folder, right-click, and go to New, Layout Resource File. We'll name this Product_Item, and then we'll click on OK. This creates a new XML file with a constraint layout as the root. Now, I've already created the views for us in a gist. You can find it at git.io/jqcxi. It will redirect you to this sample code. And watch your capitalization in the URL because it's important. Check out the link on screen. To grab the code, click on the Raw button. We're going to select and copy all, and then we'll paste it inside of our file in Android Studio. Let's close down our project view, move over to Code. Once again, we'll select all of the contents of our XML file, and we'll paste what we copied from our gist. Let's take a look at what we have in the Design view. We have a parent constraint layout with 4 items, an image view, and 3 text views. The image view holds the product image, and then we have text views for the name, size, and price. Each of the views have IDs assigned to them so that we can reference them in the code later. You can see the IDs over here in the left component tree pane. We're also using the tools namespace to set some placeholder elements, such as this image and the text values. These are denoted by the wrench next to the attribute names. So if we select our image view and we come over to the declared attributes, you see source with a wrench. That's using the tools namespace. This makes it easier for us to preview what the layout file will look like when we use it with real data. In fact, let's move over to the fragment shop class. Here, we've defined our RecyclerView. If we move over to the design pane, we can see that it's populated with just some placeholder text, item 0 all the way through item 9. Instead, on the attributes pane, over here under common attributes, we can actually set the list item as a preview. Notice that it has the wrench next to it, which means that it's going to use the tools namespace. We're going to click on the resource picker button, and then we'll choose our newly created layout, product item. And when we click on OK, notice how the RecyclerView preview has been updated to show our new product view item. This is really helpful as you can make modifications to your user interface without having to redeploy the app. In fact, I don't like how the layout item takes up so much space on the screen. I'm going to change our RecyclerView to display the items in a grid instead of the default behavior of a list. To do that, I'm going to switch over to the code view. And here where we've defined the list item, I'm going to add two new properties. First, we're going to add the layout manager. And we're going to set this to the grid layout manager. And then next, we're going to add the span count property. And we'll set this equal to 2. Now, when I switch back over to the design view, it looks so much better. We now have our items displayed neatly in a 2-column grid. With this in place, we're now ready to use our updated layout files. To connect them together, however, we'll first need to create a RecyclerView adapter. The RecyclerView adapter is responsible for supplying the data and view holders to the RecyclerView. Recall, to work with the adapter, you'll need to extend the RecyclerView adapter class and implement the following methods: onCreateViewHolder, getItemCount, and onBindViewHolder. Let's move over to Android Studio, where we'll create our adapter and implement those first two methods. There are several pieces to an adapter, which can feel a bit daunting when you're first starting out, but don't worry, I'll walk you through step by step. We'll start by creating a new Kotlin class. Here in our primary package, I'll right-click, I'll go to New, Kotlin class or file. This is going to be a class, and it's called Product Adapter. With that created, we can go ahead and close down our project pane. This class is going to have one property, a list of product items. So we'll come here for the constructor, and we're going to create a private val items, and it's going to be of type list product. And make sure you accept the imports for our product item. Next, this class will need to extend the RecyclerView adapter class. To do that, I'll come to the end of our file definition. We'll do : RecyclerView .adapter. And for now, we'll leave the parameter empty. Next, we'll need to create an inner class to serve as the view holder. View holders, as the name implies, holds our views. Since we're using view binding, we'll only need to pass in a reference to the generated binding class for our layout. To do that, we'll come inside our product adapter definition, and we'll create a new inner class, and we're going to name it view holder. As I mentioned, this needs to take in a parameter that represents our binding class. We'll name it binding, and the name of the class is always the name of the layout file in Pascal case with the word binding at the end. For us, that is product item binding. Perfect. Then we'll also need to extend the RecyclerView view holder class. To do that, we'll come right at the end of where we've defined this file so far, and we'll add a : RecyclerView.viewHolder. The RecyclerView viewHolder class needs a reference to the view as its input, so we're going to pass in the binding root. And that's it. We've now defined our view holder class. Now notice at the top here on line number 7, the view holder is complaining because we haven't implemented the needed methods yet. So what we'll do is use a quick action to implement those members. We can select Implement Members, and then we're going to choose each of the 3 methods and click on OK. Perfect. Notice how we have onCreateViewHolder, onBindViewHolder, and getItemCount. Yet each of the functions contains a to-do because they're not implemented yet. You'll also notice that we have a few question marks. That's because Android Studio wasn't aware which viewholder class we wanted to use. And for that, we're going to use our inner class viewholder. So we'll copy this name, come to line number 9, and then we'll paste in the viewholder. Notice how it's recommending this import for us. So we'll use a quick action once again, and then we're going to accept the import. Now that we have that in place, we can update the rest of the question marks. So I'll select viewholder. I'll paste it here on line number 14 for the question marks, and I'll do the same thing on line number 18. And one final update that we need to make on line number 9. Notice it says this type has a constructor, so it has to be initialized. That means we need to put our 2 parentheses here for our constructor. And that's it. Now Android Studio is finally happy. Let's go ahead and implement the first method, onCreateViewHolder. Now that we've defined our inner viewholder class, we'll need to create an instance of it that the RecyclerView can use. We'll start by coming to line number 15, and we're going to return our viewholder. To provide our product item binding class, we'll need to inflate it with the following properties. We'll start by calling product item binding, then inflate, and we're going to pass in a layout inflator, which takes in the parent's context. We're also going to provide the parent. And finally, for the attached to parent property, we're going to pass in false. We do this because the RecyclerView, not us, is responsible for determining when to inflate and present its child views. And that's it. We've defined our onCreateViewHolder method. For the onBindViewHolder, we're going to be implementing this one shortly. So let's skip to the very last function that we need to implement, getItemCount. The adapter needs to know how many items it's responsible for. So for this, we'll set it equal to the items.size. I'll come to where we have line number 31, and I'll delete everything there and set it equal to items.size. Our adapter is almost complete. Next, we want to bind the data from our product class to the viewholder. To connect the data from our model class to the RecyclerView, we need to implement the onBindViewHolder method. This method takes in 2 parameters, the viewholder, which contains a reference to our views, and an integer, which represents the index position of the current item in our list. Let's start by removing the to-do line, and we're going to create a new variable named product. We'll set this equal to the item stored in the position index of our list of items. And we do that by calling items, opening up a bracket, and we'll pass in the position variable. We now have a reference to our product object. Next, we'll use the with function on the viewholder's binding class. We'll enter an empty line, we'll type with, and then we'll grab the holder.binding variable. You can think of the with function as, with this object, do the following. We want to access the fields on the binding class, which map to those that we defined in our product item XML layout file. To get started, we'll first grab the product name text. And then we'll set its text value equal to the product.name that we get from our product object. Really simple. We're taking our object and we're binding it to our view. Then we'll move over to the size text. And we want to set its value equal to a string resource for the text. Now first, let's take a look at our string resource. We'll hit the Shift key twice, and then we'll go to strings.xml. When we scroll down to the bottom, here on line number 33, we've defined a string named product size label, and it's going to take in an integer, and then it will display milliliter bottle. And that's exactly what we want to show inside of our user interface. So let's move back over to the product adapter and get this set up. First, we'll need to get this from our resource object. And to do that, we'll use the size text, which is a view. We'll grab its context, and then from the context, we'll grab the resources. And we'll make a call to the getString function, passing in the ID of that string that we just saw, product size label. And that particular string needs to take in a product size. So we'll get that from our product object .size. Now, just to make this a little bit easier to read, I'm going to go ahead and hit enter right here. And we'll do another one here. And now everything lines up on this one screen. Great. So there's one more variable we want to set here, and that's the price. We'll grab the price text, and we'll set its text value equal to one of Android's built-in classes, the number format. From this particular class, we're going to grab the getCurrencyInstance function, and then we're going to call format on it, providing our price. This is going to make sure that we display the price in the user's local currency. Now, to connect our adapter to the RecyclerView, we'll need to make a small change in the shop fragment. Once again, we'll hit the Shift button twice, and then I'll start typing shop fragment. Here inside of the onViewCreated function, on line number 32, we're going to make a call to our RecyclerView's adapter class, and we're going to get that from the binding. So we'll start typing binding.productList. That gives us our RecyclerView, and it has a property called adapter. And we'll set this equal to an instance of our product adapter class. Now remember, this class takes in a list of items. For the list of items, we'll pass in the list of returned products. And that's it. Our adapter is ready to go. Let's run the app to see what we have so far. Perfect. We'll move over to our emulator and take a look. Let's click on the Shop tab, and we see our products displayed in the grid. The names, sizes, and prices are all loaded properly. But what about the images? Let's load those next. Coil is an image loading library for Android backed by Kotlin coroutines. One of the reasons I personally enjoy working with Coil is its ease of use. By taking advantage of Kotlin language features, the API is clean and has minimal boilerplate. I've uploaded our olive oil bottle images to our sample remote API. And then I've created a new JSON file on our remote server. This file is named oliveoilswithimagesdata.json. If we click on one of the links from the image file property, you'll see that our images have been uploaded remotely. Now, we're going to update our app to use this new API as well as download our remote images. So let's move over to Android Studio. We'll start by updating our product adapter. Inside of the onBindViewHolder function, we need to update the product image view to load the remote image file. We're going to come to where we've defined our holder binding, and we'll add a new line here. On line number 30, we're going to make a call to the product image, and then the load function. Load is an extension function that's been available from Coil. And then we'll simply pass in the reference to the remote URL, which is from product.imagefile. Now notice we have an error. We need to bring in the import for Coil. So for that, we'll use our intention action. And that's it. Now we'll need to update our JSON API. For that, we'll open up our product API class. I'm going to hit Shift twice, and then I'm going to type product API. Great. Now here, instead of calling oliveoilsdata.json, we're actually going to call oliveoilswithimagesdata.json. And that's going to point to that new file that I've updated that includes our remote image URLs. With that done, we can go ahead and run our app. Okay, let's take a look at the emulator. We're going to click on the Shop button. And now our images are loaded. But the experience wasn't so smooth. The images just seemed to pop on screen. A common way to deal with this is to have the images fade in. Let's go back to our product adapter to add in this effect. We'll go to the product adapter, and where we've added our call to load, we're going to take advantage of a lambda available from Coil. This allows you to configure the loading of your image. So we'll put in those brackets, and then we're going to make a call to the crossfade function. Notice that there are two variations. The first just takes in true false, you want to enable crossfade, and then the second one allows you to provide a duration. We're going to use the latter. We're going to set this to 1 second, which is the same as 1000 milliseconds. And we're doing this just so you can see the animation clearly. In practice, I would stick with the default, which is around 100 milliseconds. So let's run the app again. We'll click on terminate. And now that it's launched, let's go back over to our emulator. We'll click on the shop fragment. And now the image is loading slowly. Nice. With that, we've been able to load data from a remote URL, display it in a recycler view, and successfully bind the data to our user interface. Well done. Hey folks, it's time for a challenge. We're going to put your RecyclerView skills to the test. Here's what you'll be implementing. It's a basic app that contains one button, display random images. Let's give it a click. As you can tell, it contains a list of images with some information about the jobs of the fictional characters. When you click the button again, it picks a random number from 0 to 3 and then uses it to load up another set of images. We're using an API that I've created for you here at youcanlearnit.net/robots. Here's an example API response that returns a list of images along with some additional metadata. Let's move over to Android Studio to take a look at what you'll need to implement. First, I've created a skeleton application for you in the exercise files. Make sure you start there. Now let's walk through this application. The layout is similar to many of our other sample apps. We have a main activity, main view model, and then a data folder which contains our classes for loading JSON from an API. We can close down the project pane now. Inside of the picture class, you'll see all of the fields from the API response, the name, the thumbnail URL, the large URL, and then the character's job. Let's move over to the main view model. Here, we have a function, showRandomImage, starting on line number 22. This function picks a random number from 0 to 3. Whenever that value changes, we execute the code seen here on line number 14. Now, there's nothing you need to do here, but I just wanted to make sure you understood what was happening. But what you do need to implement is in the picture adapter. So let's move over to there. We have 3 functions, onCreateViewHolder, onBindViewHolder, and getItemCount that all need to be implemented. These are needed to power the display of the items in the recycler view. Speaking of the recycler view, it can be found inside of the layout file for the main activity. So if we move over to activity_main, you'll see our recycler view on line number 43, the ID is pictures list. This recycler view uses a linear layout manager. Each of the items in the layout will be of type picture item. So if we take a look at picture item, you'll see that this particular file has 3 items: an image view for displaying the image URL, and a text view for the character's name, as well as for their job. You'll need to bind the fields of the picture data class to these views in your adapter's onBindViewHolder method. Now, if you get stuck, refer back to the previous videos where I walk through how to create a RecyclerView adapter. Additionally, make sure you watch the solution video where you'll see how I tackled this challenge. Bye for now. Welcome back. Let's jump into my solution to the Random Picks challenge. I wanted you to update a skeleton application to properly display a dynamic list of pictures in a recycler view. Everything was implemented for you in the data layer. Your task was to implement the methods needed for the picture adapter class. Let's start with onCreateViewHolder. Since the viewholder class was already defined, I needed to create an instance of it that the recycler view could use. It required a picture item binding class. To provide the picture item binding class, I inflated it with the following properties: the layout inflator from the parent context, which you can see here on line number 19, the parent on line number 20, and then I set attached to parent equal to false. Remember, we pass in false for this parameter because the recycler view, not us, is responsible for determining when to inflate and present its child views. Now on to onBindViewHolder. Here, we first get the picture. We do that by accessing it from the items array and the position integer. Next, using the with function, we pass in the holder.binding. This is the object that's holding all of our views. And then we simply populate each view. The picture image using coiled load function, and then on line number 31, I used the crossfade in order to have it to slowly fade in. And then on line 33 and 34, we set the name and job text respectively. Did you decide to use the crossfade function as well? If so, kudos to you for adding that little touch. And finally, the getItemCount function on line number 38. This returns the items.size. And that was the final change that was needed to complete this challenge. Working with the recycler view is one thing you'll find yourself needing to do time and time again. Hopefully you feel more confident doing so now. By default, clicking on an item in a recycler view fires off a click event. But to take any action on it, such as taking your user to a new screen, you'll need to add a click listener. Let's move over to Android Studio to configure our app for handling click events. Now, although the event is fired from within the recycler view, we actually need to handle it in the parent class, which is typically a fragment or an activity. For us, we've defined our product recycler view and adapter here in the shop fragment class. So this is where we'll need to handle a click event. We'll start by creating a private variable right here on the top of the class on line number 17. And we're going to name this onItemClick. It's going to be of type lambda. The syntax for a lambda is the following. We'll put a pair of parentheses. Inside, we'll put the type that we plan on sending in, which is a product. And let's go ahead and hit enter so we can bring in the import. Then we'll put a space, an arrow, and then the return type of our lambda. In this case, since it's a click listener, it's going to return unit. And then we'll set this equal to the following. It's going to equal the lambda, which takes in IT of type product. And so to make that more explicit, let's actually rename it to product there. And then for now, we'll simply print whatever product we get back to logcat. To do that, we'll make a call to the Android log method .I, and we'll pass in our global log tag. And then we're going to print out the string, the selected product. Let's put a colon and then $product to print out the value of that variable. And the one last thing we need to do is accept the import. Okay, at this point, this lambda is now the link between our fragment and the recycler view. But how can we make the connection? That's by means of our adapter. We're going to pass in our onItemClick lambda as an input to the adapter. To do that, we'll scroll down to where we've created our adapter here on line number 39. And right beside where we send in the products, we're going to send in the onItemClick variable. Now, keep in mind, we haven't changed the product adapter yet, so that's why we're seeing the error. In order to fix this automatically, we can go down to where it gives us the recommendation, add parameter to constructor product adapter. And we're going to just click on that. And as you see, it adds the onItemClick lambda. So let's go ahead and click on refactor. Now we'll also need to make a few additional adjustments to the product adapter as well. Let's move there. Here inside of the product adapter, the first thing I want you to notice is that our onItemClick variable has been added. Now that it's available, We want to be able to call this lambda whenever the user clicks on one of the product items in our list. We'll do that in the onBindViewHolder function. When we scroll down here, you see that we have access to the specific product that's being bound at this moment. The view holder also has a special property, item view. This points to the base of the view element. We'll use this property and set a click listener on it. That way, no matter where the user clicks, we'll be able to capture it. So we'll come down to beneath the with function. I'll hit enter a few times to give us some space, and then we'll make a call to our holder.itemView. We'll call the setOnClickListener, and then we're going to pass in the onItemClick function that we've defined earlier. And this will take in our specific product. Now right now we're getting a little bit of an error because it says, I don't know where the onItemClick function is found. To fix that, we're going to scroll up to the top, and instead of leaving it hanging this way, we'll actually add private val. And now it's going to be accessible everywhere within inside of our adapter. And that's all we needed to do here. So as we scroll back on line number 43, we see that the error has now gone away. This way, whenever we make a call to the onItemClick lambda, providing the current product that was clicked on, we're going to be able to see the result. And that's it. We've established the connection between our fragment and the RecyclerView. Let's run the app to test it out. We're going to click on Reinstall and Restart. And let's terminate. And now our launch has succeeded. So when we take a look at the emulator, we're going to come to the shop fragment. And so far, everything looks the same. If we click on an element, nothing seems to happen. We clicked chili and we clicked on bold. But let's go back to Android Studio to check out the logs. We'll come here and we'll click on logcat. And then we'll filter for our tag, 2 trees oil. And you'll see that we have 2 log statements. The first one says the selected product was chili, and then the second one, the selected product was bold. This means that we were able to listen to the click events and properly determine which product was clicked on. Perfect. On Android, there are multiple ways that users can navigate from one screen in your app to the next. So far, we've used intents to navigate from one activity to another. Recall, intents are simple classes that allow you to send messages to other components. You start in one activity, and you use the start activity method to send an intent. The Android system processes your intent, and then it decides which component is available to handle it. Creating intents can be straightforward, like the example you see here. When the user clicks on a button, we create an intent, and we navigate them to the main activity class. We've also used fragment transactions to navigate from one fragment to another. Yet we've only scratched the surface of these APIs. They can become more cumbersome when you need to share data between screens, add animations, or ensure proper handling of the back buttons and arrows. This is where the Jetpack navigation library comes in handy. It's comprised of 3 primary components: a navigation graph, a host fragment, and a controller. These all work together to move users throughout your application. Some of the key benefits of Jetpack navigation are that it handles fragment transactions behind the scenes. It handles the up and back actions correctly by default. It provides standardized resources for animations and transitions, as well as provides type safety when navigating and passing data between various destinations. Let's learn how we can use the navigation library in our 2 Trees olive oil app. We'll move over to Android Studio and get started. We'll start by adding the needed dependencies to our app's builds.gradle file. I'll paste them here on line 52. It's the navigation fragment KTX library as well as the navigation UI KTX library. And then we'll click on sync. Once that completes, we're ready to use these dependencies inside of our project. Perfect. We'll start by creating our navigation graph. To do that, we'll go over to Project, right-click on the Resources directory, and go up to New, Android Resource File. We're going to name it nav_graph, and for the resource type, we'll choose navigation from the dropdown and click on OK. This creates a new folder named navigation if you didn't have one previously, and it adds an XML file, nav_graph, which we'll use to define the various destinations inside of our application. So we'll close this pane down and we'll use the design view to get started. We'll click on this new destination button and we'll start by choosing the home fragment. This is going to be the initial destination of our application. So let's move that over here to the left. And then we'll add more destinations for each of our primary tabs. The Tours tab, as well as the Shop tab. Now, since we want to be able to navigate to a detail view, we'll do something special with the Shop fragment. We're going to create yet another destination, but this time it's going to point to the detail fragment. Now, I've gone ahead and created the detail fragment for us. This is a very simple view that displays some information about the particular product that a user clicks on from the list. So to associate these two destinations with each other, we'll click on the Shop fragment until it has that blue border, and then we'll use the blue circle and drag it over to our detail fragment. We've now established a relationship between the Shop fragment and the detail fragment. We're almost ready to use the component. We'll switch to the code view in order to update a few IDs. Since we want to use our bottom navigation view, we need to make sure the IDs are matching between the navigation component and the bottom navigation view. You'll see what I mean in 1 second. So instead of having the ID home fragment, we're going to change it to action_home. This is the same ID that we use for our bottom navigation view. We'll also update that here under the start destination. And we'll do likewise for the Tours fragment. It should be action Tours, and for the Shop fragment, it's going to be action Shop. Now I want to point out something unique about the Shop fragment. Unlike the other fragments, it has a nested element named action. That action has an ID of action Shop fragment to detail fragment, and it has the detail fragment as the destination. This is the code representation of us dragging that blue circle and creating that arrow from our Shop fragment to our detail fragment. Keep this ID in mind as we'll be using this shortly in order to handle when the user clicks on an item. The next thing we need to update is our main activity XML file. Previously, we had this frame layout here, and we were swapping and removing fragments using fragment transactions. But since we want to switch to using the navigation component, we're going to have to update this a little bit. We'll start by changing this to a fragment container view, and then we'll add the property Android name. We're going to set this equal to AndroidX.navigation.fragment.navHostFragment. Now this is important because we want to be able to find this inside of our main activity class. Next, underneath where we've defined some core properties about the width, the height, and the weight, we'll also add a few extra attributes. The first is the navGraph attribute, and this is going to point to our navigation XML file. And the final attribute is the default navHost attribute. And we're going to set this equal to true, as we're not going to have any additional nav hosts inside of our application. Now our activity XML file is all done and ready to go. We'll move over to the main activity class. Here on lines 24 through 38, we were using fragment transactions in order to handle the navigation of the buttons on the bottom navigation bar. This is no longer needed because we're using the navigation component. Instead, we want to connect our bottom navigation bar with the navigation controller. So we'll delete everything you see here, and we'll create a few variables. The first is a variable navHostFragment. And we're going to set this equal to the support fragment manager, and we're going to find fragment by ID, and we want this to be equal to the ID of our navHost fragment. So that was r.id.container. And we're going to use as navHostFragment. And this is important because we want to make sure we can get the nav controller from it. On the very next line, we're going to create a variable nav controller. And this is going to equal the nav host fragments nav controller. And finally, we'll set up our bottom navigation bar to take advantage of it. We'll use the setup with nav controller function, and we'll pass in our nav controller. Now let's summarize what we've done on these 3 lines. We've gotten access to our nav host fragment that we defined in our activity main XML file. Then, from the host fragment, we got the nav controller there on line number 28. And finally, on line number 29, we set up our bottom navigation bar to use this nav controller instead of the previous logic that was taking advantage of fragment transactions. If we scroll down more in the main activity file, that means we no longer need these private functions that were creating fragment transactions, so we can simply remove them all. Now our code is much shorter and easier to read, as well as to maintain. The last step is to navigate to the detail fragment whenever someone clicks on that button. For that, we'll move over to our shop fragment class. Remember, we created this lambda on item click. We're now going to use it to send the user over to our detail fragment. For that, we simply need to get access to the nav controller, which we can do with the find nav controller function. Then we're going to navigate to that ID that we defined previously, which was r.id.action_shop fragment to detail fragment. Let's run the app to verify our use of the navigation component. Just like before, when the app first opens, we see our home screen, which is great. And when we click on the Tours button, we're taken to the Tours screen. And we click on Shop, we're taken to the Shop screen, and our products load in. Wonderful. The last thing that we wanted to check was what happens when we click on a particular item. Let's click on the bold bottle. We're taken to a detail screen. But right now, we see chili. So what happens? Well, it's hard-coded to only display the first product in the list, regardless of which product we select. We'll now move on to implementing the correct behavior by taking advantage of our shared view model. Like most things on Android, there are multiple ways that you can share data between components. One simple way is by storing data inside of a shared view model. So far in our application, whenever a user clicks on one of the products, they're always taken to a detail screen that shows the same hard-coded information. To fix this, we'll update the shared view model to store the actual product that the user selected. Here inside of our shared view model class, starting on line number 10, we're going to create a new variable. We'll name this selected product. This variable is going to be of type mutable LiveData, and it's going to hold a product object. Let's go ahead and create a new instance of our mutable LiveData class. We're choosing mutable LiveData here because we want to be able to change the value each time the user clicks on an item from the list. To do this, we'll go to the shop fragment, and here on line number 20, we've defined our onItemClick listener. First, we simply log the selected product, and then next, we're going to get access to our shared view model that we've defined there on line number 16, and we'll make a call to the selected product mutable LiveData variable, and we'll update its value to be equal to the product that we receive in our Lambda here. The final step is to update the code in the detail fragment. When we move to that class, we see that we have a function right here on line number 34. We're using our view model to observe changes to the products list, and then when we receive an update on line number 35, we simply pick the first product and then we update all of our binding. Instead of doing this, we want to change to using the selected product mutable LiveData variable. And when we get back its information, it's just going to be one product. And so then we'll update line number 35 to be product. Everything else will be exactly the same. Now let's go ahead and run the app. Once our app launches, we can navigate to the shop fragment, and then let's choose one of our products like basil. And we see that it properly loads the selected item. As we navigate back and forth between the shop screen and the detail screen, we see the appropriate products each time. Jetpack components have enabled us to have a relatively complex interaction in our application with minimal code. I encourage you to learn more about the navigation library by reading the documentation available at developer.android.com/guide/navigation-principles. Here, you'll find more information about the principles of navigation and other features that are available to you in this powerful library. Hey folks, it's time for our final challenge. We're going to be building upon your newly acquired skills with the Jetpack navigation library. Here's what you'll be implementing. We're building on our previous challenge where we had a sample app that displayed random images. Recall, when you click the button, a list of random images appears below. What's new is what happens when you click on one of the items. You're taken to a detail screen with a larger image and the character's name and occupation. And then when you click back, you're brought back to the list of images. Let's move over to Android Studio to take a look at what you'll need to implement. Using the skeleton application from the exercise files, you'll have to modify two files in this sample app. First, you'll need to add a new resource for the navigation graph XML file. The activity main layout expects the file to be named nav_graph. You can see that here on line number 38. Your graph should start with the main fragment and then have an action that links to the detail fragment. The final change you'll have to make is inside of the main fragment class. You'll need to implement the to-do that you see here on line number 24 inside of the onItemClick callback. You'll want to replace this to-do statement with a call to the nav controller with the action ID from your graph. If you get stuck, take a look at the previous videos where I show you how to create a navigation graph. Additionally, make sure you watch the solution video where you'll see how I tackled this challenge. See you soon! Welcome back. Let's jump into my solution to the Lights Camera Action challenge. For this challenge, you needed to create a navigation graph and then use it to navigate from a list to a detail screen. Let's take a look at my solution. First, we'll look at the navigation graph. Using the new destination button, I created two destinations, the main fragment and the detail fragment. Then I connected them to each other, starting from the main fragment and then over to the D fragment. If we take a look at the code, then you'll see the generated action ID. That's here on line number 14, action_main fragment_to_detail fragment. We'll need this for our nav controller. Over in the main fragment class, here on line number 24, I use the nav controller and I make a call to the navigate function, passing in that action ID. That's it. Working with the navigation library makes moving between screens a breeze. I hope you had fun giving our final challenge a try. We're done! Congratulations! You've completed part 4 of Android Development Essentials training. You've learned how to start developing data-driven apps. First, by using Android resources to store and load JSON data with the Moshi parsing library. Next, you learned how to get data from a web service using the popular open source library Retrofit. And finally, you became proficient with displaying data inside of a RecyclerView. I hope you feel more confident than ever with your Android skills. I always say that one of the best ways to move forward with Android development is to practice. Use the sample apps that I've created for you in this course as a foundation for making something of your own. You're now capable of creating complex applications that download and store users' data. They're also composed of multiple screens. Put those skills to use. Also, be sure to check out the other courses in the Programming Foundation series. This will give you more ideas about what's possible with the code you're writing and the apps you're creating. I really enjoyed putting this course together for you, and I wish you continued success on your Android development journey.